Hello students, welcome to one more amazing session from Infinity Land. This is Suresh, Faculty of Chemistry. Today we are going to discuss about hydrogen spectrum. So students are continuously asking a question, can we see the atom by using a sophisticated equipment? Yes, of course we can't see directly an atom, rather you can see the image of the atom. So what is the meaning of the image of the atom? It's a photograph. This photograph is just like a caricature, like a cartoon film. No, it is like a scientific picture of the atom. That is nothing but spectrum. The first fundamental spectrum is defined for hydrogen spectrum. Let us see the details of hydrogen spectrum, unveil the structure of atom. Based on this, you are going to get a question from NEET examination. Before going for this details of hydrogen spectrum, I just want to introduce you Atreya program. So this Atreya program is for this droppers and it is more efficient program. Let's change our set of mind from I didn't do to I will do. Yes, crack your NEET examination. Sri Chaitanya Academy by Infinity Land introducing proudly the program Atreya program. And this Atreya program link is there in the description box, and click this link and enjoy your program. I am going to discuss fundamentally about what is this program. This Atreya program, India's most powerful program for NEET aspirants and NEET repeaters, and revolutionizing NEET preparation for P-square CB program. What is this P-square CB program? And NEET exam preparing students, the nightmare subject is going to be physics, and you witness it. 2025 physics paper is slapped like anything, and this Atreya program is giving the best emphasis for the physics program and the double focus on physics with chemistry and biology. And enroll now and click the link available in the description box. And you can see the details about the structure is batch commencement starts already शुरू हो चुका 23rd May को और दूसरा बैच भी शुरू करने वाला है. And you are going to have the sessions from Monday to Saturday, and Sunday को छुट्टी है. And duration of each class is going to be 90 minutes. You will be having classes per day, 3 classes. In that 2 are going to be concept classes and 1 is going to be physics. And for the physics, you will be having a double practice sessions. And Infinity Learn is going to take care of the physics, and we're going to take the common problem of the entire NEET aspirants. The physics is the toughest and hardest topic for you. And it is on us, don't worry, from now onwards physics will be the easiest and understanding and simple subject for you after Atreya. And you can see there will be interactive live sessions by expert faculty, 465 interactive sessions, my dear children, and you will be having 240 DPPs and dedicated practice classes, around 120 classes plus. And also after every class you will be given a session notes in the PDF format, and also you will be having a very good and healthy batch setting for the practice sessions. Maximum 20 to 25 students will be there, and for this you will be having very good rapport and interaction with the direct expert faculty, and also coverage of the total 11th to 12th. And this is all about this Atreya program, my dear students. Those who are completed NEET examination 2025, you can go for the rank of prediction. The link is there in the description box, and you can do the best for your NEET preparation and also for your college prediction and rank prediction. Now let us start. Our day of interest is a spectrum. The spectrum, you see, it is in a spectrogram or the spectrum. When this light is passed through a prism, it is going to resolve into its constituent wavelength like a violet, indigo, blue, green, yellow, orange, red. And this collection of wavelengths that is appearing here, it is called as a spectrum. And this spectrum can give you the insight about how the atom is there. So before going for this hydrogen spectrum, let us talk about the different types of spectrum. Classification of spectrum. Spectrum is basically on discontinuous spectrum and continuous spectrum. And discontinuous spectrum is our further 2 types, line spectrum and band spectrum. So let us see what is a continuous spectrum. discontinuous spectrum, line spectrum and band spectrum, so that eventually we go into the hydrogen spectrum. And you can see, yeah, the spectrum classification based on origin, how you got this spectrum. So it is of line spectrum, emission spectrum or absorption spectrum. The spectrum obtained by absorption of radiation is called as absorption spectrum. I wanted to say a light is passed through a cold gas. So the gas is going to absorb some wavelength in it, and the rest of the wavelengths are going to be emitted. That is called as absorption spectrum. And emission spectrum, when the gas is heated so that all the atoms and electrons are excited, and in the dark they are going to de-excite, and it gives a radiation in the form of light and gives the emission spectrum. So absorption spectrum is obtained while the electron is getting excited, while the emission spectrum is obtained when the electrons are going to be de-excited. So the excitation process gives absorption spectrum, children, and the emission process of the electron is going to get emission spectrum. I just want to say one thing here. If you see, this is the atom, this is the lower shell, okay, and this is going to be higher shell. When the electron is jumping from lower shell to higher shell, this is called excitation. During excitation, energy is being absorbed into it. While the electron is coming from higher shell to lower shell, so energy of the electron is emitted. So this is emission. This is what is called as absorption. So during this process, you are going to get a spectrum that is called as the absorption spectrum, and this is going to be emission spectrum. Now let us see the details about this continuous spectrum and the discontinuous spectrum. So continuous spectrum means a spectrum in which all wavelengths are going to be continuously seen. There is no gap between the wavelength to wavelength. You can see violet, indigo, blue, green, yellow, orange, red. Now can you see the gap between blue to green? Can you see the gap between violet to indigo? Can you see the gap between orange to red? There is no gap, that is merged. So that spectrum is called as continuous spectrum. Okay, and let us talk about discontinuous spectrum, that is called discrete spectrum or discontinuous spectrum. And this discrete spectrum, there is a spectral line, there is this is equal to a wavelength, and this is an equal to wavelength, but there is a defined remarkable gap between the wavelength to wavelength is called as a discontinuous spectrum. And this is of two types, line spectrum. Line spectrum means a discrete lines are observed, they are called as line spectrum. Actually this line spectrum is obtained by the atoms when the atom has electron excitation, de-excitation gives rise this line spectrum. And talking about this band spectrum is produced by the molecules. These molecules contains a group of atoms. These atoms are going to rotate and vibrate, and this rotation and vibrations of the atoms in the molecules gives rise the band spectrum. You can see a stretch of band is observed like a discrete lines, a bunch of lines are observed as this band is called as a molecular spectrum or the band spectrum. Hope you are understanding the difference between the line spectrum and band spectrum. And the line spectrum is used to characterize the atom, and the band spectrum is used to characterize the molecules. So line spectrum is also called as a atomic structure, atomic spectrum, and band spectrum is also called as a molecular spectrum. Okay, talking about emission versus absorption spectra, when the electron is going from the lower shell to higher shell, it is absorption of energy. When the electron is coming from higher shell to the lower shell, it is going to give the emit energy. So absorption of energy gives a absorption spectrum, emission of energy gives rise emission spectrum. And how these levels of the atom in various shells can be explained on the basis of the hydrogen atom. Now बच्चों, Emission spectra. Emission spectra, when this gas discharging tube containing hydrogen is taken, when high potential is observed, so that it is going to give a lines, and this is what is called as hydrogen spectrum, hydrogen emission line spectrum, you can say this. And this is given as, this is a gas sample, cold gas sample, when a white light is passed through it, and the some of the wavelengths are going to be absorbed here, and this is going to produce, this is called as absorption spectrum. And this absorption spectrum, some wavelengths will be missing, and you can see line spectrum of hydrogen, this is also called as de-excitation series and emission line spectrum of hydrogen. And this line spectrum of hydrogen can be observed when you talk about this hydrogen. Actually, the atom is said to be spherical, and the lines are going to be like this. Instead, for that, our convenience sake, the shells are given and the parallel lines. When these electron in n is equal to 1, n is equal to 2, n is equal to 3, 4, 5, 6 up to infinity, if the electron is jumping from higher shell to lower shell, it is going to have energy loss. How much energy loss we can see in this shell number 1, 13.6, minus 13.6 is the energy. Shell number 2, minus 3.4, energy of the electron is given as minus 13.6 into Z square by N square electron volt. From this formula, you can say this is the energy value of this first shell, second shell, third shell, minus 1.51, 0.85, minus 5.54 for electron volts. Let us say an electron wanted to jump from here to here, it has to gain the electron 10.2 electron volt. Similarly, if the electron want to jump from here to here, it has to lose 10.2 electron volt. Similarly, it is going to jump from here to here, it has to lose 12.09 electron volts. While losing this energy, it is going to form various spectral lines. That spectral lines are seen as when the electron in the excited state jumping from higher shell to n is equal to 1, it is going to lose energy in the form of radiation, and that radiation is going to form a line on the hydrogen spectrum, and that line is first observed by a scientist called Lyman, that is called Lyman series. If the electron is jumping from higher shell to the second shell, and it is going to release energy, and this released energy in the visible region, it is the first spectral line, in fact, is observed by Balmer. So, the first spectral line observed by Balmer. And when the electron is jumping from higher shell to the lower shell, jumping to n is equal to 3, it is going to be Paschen series, and it is going to be Brackett series, and it is going to be Pfund series. Pfund series. Like that, Lyman series, Balmer series, Paschen series, Brackett series, Pfund series is a series of lines are observed when the hydrogen gas is subjected for the discharge. And this spectral lines has a wavelength. This wavelength gives the insight of this impression of the scientific impression of the hydrogen atom. And this is going to be your hydrogen spectrum. Lyman series is found wavelength in the range of ultraviolet region. Balmer series is found in the range of visible region, and Paschen series, Brackett series, and Pfund series, it is in this infrared region. Like you see, near infrared region, middle infrared region, far infrared region. Like that, it is given. Okay. Now, Balmer was the first scientist. He was in 1885 on the basis of experimental observation and the wavelength of the spectral lines and the wave number of the spectral lines. He has given the Balmer equation. Later, this Balmer equation, it is not there in NCERT, it is not required for NEET examination. Just I want to tell you the history behind this hydrogen spectrum. And Ridge and Rydberg were the mathematicians taken the spectral line data, and they given the Ridge-Rydberg equation. And this is called as Hc by lambda is equal to 2.18 into 10 power minus 18 of 1 by n1 square minus n by n2 square. What is n1 square? n1 is to which shell an electron is coming. while N2 is going to be from which shell an electron is coming. That is very important. And Hc is taken here, so that 1 by lambda is equal to nu bar is equal to 2.18 into 10 power minus 18 of Hc of 1 by n1 square minus 1 by n2 square, and the entire thing, H is a constant and C is a constant. Planck's constant, light velocity are substituted here. It is coming to be 1096780 centimeter square, or otherwise you can say 1 by lambda is equal to 109677 of 1 by n1 square minus 1 by n2 square centimeter inverse. So the R value is said to be 109677.8 centimeter. This is the actual value. Let us simplify this. So NEET examination, this much big value, who is going to use it? You can use it on simplified version. Dear students, this is the decimal. So I wanted to say this is 1.09677812345 into 10 raised 5. Okay, centimeter inverse. Otherwise, you want to just simplify this 1.1 into 10 raised 5 centimeter inverse. So you can use this R value. You can use this R value on a simplified version. Are you getting or not? And even I have a super awesome trick, my dear children. 1 by R is equal to 912 angstrom units. That's it. You can calculate so many things based on this. So majority of the questions can be calculated by using this trick for your NEET examination, believe it or not. Okay. Now 1 angstrom units can be converted into 10 to the power of minus 8 centimeter if you want. Okay. That's very, very, very important. That's very, very important. Got it? Clear? Wonderful. So if any doubt you have, you please mention in the comment box, and please like this session, share with your friends, subscribe to Infinity Learn NEET YouTube channel. Okay. Now talking to what about the spectra of the other elements? For all other elements, hydrogen atom like species, 1 by lambda is equal to R z square of 1 by n1 square minus 1 by n2 square centimeter inverse. It is given as R is equal to, we know that it is 109677.8, that is for the hydrogen, and Z is the atomic number. Z is the atomic number. So this Z atomic number, let us talk. Z is the atomic number. Hydrogen and hydrogen like species. For hydrogen, atomic number 1, helium plus atomic number 2, lithium 3 plus atomic number 3, beryllium 3 plus atomic number 4, it goes like this. And let us talk about, analyze the spectral series of the hydrogen for the Lyman series. So what is Lyman series? So this is the 1, 2, 3, and it is going to be 4, and it is going to be infinity. If the electron is jumping from anywhere to n is equal to 1, this is the first spectral line, alpha line, and this is the second possible line, that is called beta line. This is the third possible line, that is called gamma line, and this is called series limit. Series limit. So highest energy, lowest wavelength, I just want to say the lambda minimum, and it is going to be lambda maximum. That is given in this. It is found in the ultraviolet region, 1898 it is found by Lyman, and the value of n1 is equal to 1, n2 could be 2, 3, 4, so on, and from the ground state. So for this, 1 by lambda is equal to R 1 by 1 square minus 1 by 2 square, where n2 is greater than always 1. Okay. And wavelength of the marginal n1 square by Rydberg constant for all series, and this is super important point for your NEET examination for Lyman series. Lambda is equal to 1 by RH. Fine. And let us talk about the Lyman series over here. The first line in Lyman series, it is said to be 2, 2, 1. Second line, this is called H alpha Lyman, and the second line is called as H beta line, and last line is going to be H series limit, H limit, okay, and it is going to be 12400 upon 13.6 angstrom units is less than Lyman, okay, and this information can give you a lot of insight about this. And also you can see in the Lyman series, the longest line is going to be lambda max is equal to 12400 upon energy minimum, and shortest line is equal to lambda minimum is going to be 12400 upon delta E maximum, and first spectral line longest wavelength, the last spectral line the shortest wavelength, that I already mentioned to you guys. And also maximum number of spectral lines, that is different photons, it can be observed by using the formula. You have maximum number of spectral lines, that is equal to n2 minus n1 of n2 minus n1 plus 1 by 2. So by using this you can calculate the maximum number of spectral lines. You can see when the electron is jumping from higher shell to lower shell, let us say fourth shell to first shell, how many spectral lines can be observed? Each jump is going to be each line. So 4231, 422, 421, 322, 321, 221, total 1, 2, 3, 4, 5, 6 spectral lines are observed. So I want to tell maximum number of spectral line is equal to n2 minus n1, n2 minus n1 plus 1 by 2. So I mean to say 4 minus 1, 4 minus 1 plus 1 by 2. So it is going to be how much it is coming, you just mention in here, total 6 are coming. So you can calculate manually as well as by using a shortcut method. That is what it is said. Okay, my dear children, here I just want to show you the summary of the hydrogen spectrum. This summary of the hydrogen spectrum, you can see it is going to be series, Lyman series, Balmer series, Paschen series, Brackett series, and Pfund series, and these are the various series. And to which electron is coming to the shell is said to be n1 value. For the Lyman series, n1 value is equal to 1, and n2 value is going to be from which shell an electron is coming. If the electron is coming to n is equal to 1, it can come from the 2, 3, 4 and 5, it goes like this. And the Balmer series, electron is coming to n is equal to 2, so it is coming to be 3, 4, 5, 6 or so on. Paschen series, it is going to be 3, so electron is coming from 4, 5, 6 or so on, and it is going to be 4, and it is going to 5, 6, 7, 8 or so on, and it is going to be 5, 6, 7, 8 or so on. Okay, so what is the region of the light they are going to provide? Here it is going to be region of light, it is going to be region of light, it is ultraviolet region, and it is going to be visible region, and it is going to be near infrared region, it is going to be middle infrared region, it is going to be far infrared region. Understand? Clear? So every spectral line has its own wavelength. That wavelength can be calculated by using 1 by lambda is equal to Rz square of 1 by n1 square minus 1 by n2 square. So wavelength 1 by lambda is equal to nu bar, wave number, and R is this Rydberg constant. Its value is 1096777.8 centimeter inverse. You want to shortcut it? You want to shortcut it 1.1 into 10 to the power of 5 centimeter inverse. You can do it. Or otherwise a super important formula. 1 by R is equal to 912 angstrom units. Use this super awesome trick to solve these questions. And while Z is equal to over here atomic number. Okay. So this is the overall picture about the hydrogen spectrum. Based on this hydrogen spectrum, you will be having a question from the NEET examination, even in the boards also. And hope like this today, you like this session and experienced what is spectrum, types of spectrum. Today we discussed about hydrogen spectrum and various types of spectrum, absorption spectrum, emission spectrum, line spectrum, band spectrum, and eventually we enter into the atomic structure, atomic spectrum. In that hydrogen spectrum we studied, and we calculated various wavelengths of Lyman, Balmer, Paschen, Brackett, Pfund, and I have given you the best trick for the Rydberg constant also. Please like this session and share with your friends and subscribe to Infinity Land NEET YouTube channel. Thank you.